The Königsberg School gives the grades 1 through 7 to 7 pods. A through G. 1 grade to each pod. Some pods are joined by walkways. And any 2 pods joined by a walkway must get grades that differ by 2 or more. For example, grades 1 and 2 can't be in directly connected pods. Using the walkways shown, what is the sum of the grades at pods C, E, and F? You can pause here and solve the problem before seeing the solution. Here is the key to the whole puzzle. Differing by 2 or more just means 2 joined pods can never get consecutive numbers. So next to a 4 you cannot place a 3 or a 5. Now look at how busy each pod is. Pods A and F each have 5 walkways. More than any other pod. A pod with 5 neighbors has to differ by 2 from 5 different grades. The only grades that manage that are the extremes. Grade 1 clashes only with 2. And grade 7 clashes only with 6. So A and F must be 1 and 7. Let's set F equal to 7 and A equal to 1. Next, where can the leftover extremes go? Grade 6 clashes with 7. So it can't touch pod F. The only free pod that isn't joined to F is G. So G is 6. In the same way, grade 2 clashes with 1. So it can't touch A. The only free pod not joined to A is E. So E is 2. That leaves grades 3, 4, and 5 for pods B, C, and D. Pod C is joined to G, which is 6. So C can't be 5. And C can't be 4 either. Because then its partners would have to be 3 and 5. Both too close. So C is 3. That forces B to be 5 and D to be 4. Every walkway now differs by at least 2. So the labeling works. Adding the 3 we were asked for. C is 3. E is 2. And F is 7. 3 plus 2 plus 7 is 12. And the mirror labeling, replacing each grade by 8 minus itself, is also valid and gives the very same sum. The answer is 12.